to JMath.
Welcome to the first video for grade 11. Many schools start in chapter 2, others start in chapter 1, but let's go for chapter 2. So we're going to look at anything and everything you need to know about exponents, starting with the laws of exponents in this video. Good luck. So now let's look at each law a bit more closer. So if I zoom in on law 1, when you multiply and the bases are the same, you must add exponents. So if x to the power a times x to the power b, that would have an answer of x a plus b. So you will notice I'm not changing the base. I'm only writing one base and I'm adding the exponent. So let's put numbers to this so you can see what I mean. 2 to the power a times 2 to the power 5 is not going to turn into a 4. It's going to turn into a single base of 2. I write a 2 and then I just plus the exponent. Please guys, never ever make this a 4. It's always just the same base. Law 2 says the same thing, but now when you divide and the bases are the same, you must subtract the exponents. Okay, so x to the power a over x to the power b. Remember, a fraction means divide, and that's why I just write 1x and I say the top exponent minus the bottom exponent. So yes, it says divide in the law, but in grade 10 to 12, you are never going to see a divided sign. You can, but it's very rare. So you would rather have fractions. And you must always remember, I write one base and then the top exponent minus the bottom one. And that's why the answer to the right for 2 to the power a over 2 to the power 5 will be 2 to the power a minus 5, all in one exponent. The next law, so I'm not saying law 3 because textbooks differ and the numbers change. So you must just know all the laws. Doesn't matter which number it is. But this one says, when there is an exponent inside and outside the bracket, you must multiply exponents. So x to the power a in a bracket, and then a b on the outside of the bracket will just be x to the power ab. Okay, if we look at the example with numbers, 2 to the power a in a bracket to the power 5 will just be 2 to the power 5a. And now remember, if I can simplify something, I should simplify something. And that's why 2 to the power 5 becomes 32a. So if it's possible, please always simplify. The next one says, when there are many bases inside a bracket and an exponent on the outside, you must multiply each of the bases inside with the outside exponent. So x times y in a bracket to the power a will become x to the power a, y to the power a. And if we look at our example, now it is 2a in a bracket to the power 5. I give that 5, I give 2 each base on the inside. And that's why the answer will be 32 times a to the power 5. Make sure this makes sense, guys. So this law and law 1 is very close. But in law 1, we plus the exponents because there's a times between them. And in this law, we multiply because there's a brackets between them. So yeah, don't get confused. I know this seems very, very tricky. The next law is very much the same as what we just discussed. Now it's just a fraction on the inside of the bracket. So the same rule applies. The outside exponent goes to the top, the numerator, and it goes to the bottom, the denominator. And that's why with our example, 2 over a, all to the power 5, will just be 2 to the power 5 over a to the power 5. So the top and the bottom gets that outside exponent. Now there's just a few things that you always need to remember. So it's not officially laws, we call it applications of exponents. And the most important one is anything to the power 0 becomes a 1. So if it's just an x to the power 0, it's 1. If it's an actual number to the power 0, it's 1. If it's an entire bracket to the power 0, the answer would still just be 1. So don't argue, don't wonder why. If anything is to the power 0, the answer would just always be 1. And now another one, which you will see the most, if they want to make the sum difficult, they're going to put negative exponents there. And that just said, if there is a negative exponent, it would flip the base. Or if something is already a fraction, it would just move everything to the other side of the fraction. So if a base has a negative exponent, it moves to the other side of the fraction. We're going to do a few examples and you're going to see exactly what I mean. So with the left one, x to the power minus 1, I'm just going to flip it and say now it becomes 1 over x. So many people ask me, but where did the exponent 1 go? It's still there. I can just write it there. But because it's a 1, I never write it. Okay, the other one, if I have a fraction with a negative exponent, I just flip the fraction. Okay, so both of these still have an exponent 1, and this minus you can write at the bottom, at the top, or just to the left. Doesn't matter, as long as your answer just has 1 minus, you will be correct. In the next one, so now you must focus very clearly. So there's a 3, the a has a negative exponent, and the b does not have a negative exponent. So I skipped a step here. The middle step that I skipped would be if I just keep the ones with a positive exponent up top, and I move the a to the bottom because it has a negative exponent, then all of this to the power minus 1 is where we get our answer. So I just flip the base in the fraction. So all of these you learned from grade 9, grade 10, and now this is the one that's more prevalent in grade 11. If you have a root, there's a specific way to rewrite that root in exponent form. So remember, a square root has an invisible 2 in front. And the rule says, if I need to rewrite a surd into an exponent, I need to check what is the inside exponent and what is the front or the outside exponent. In this case, the inside exponent is a 1, and the surd exponent is a 2. So if I rewrite it, it's going to be the base, x, to the power 1 over 2. Okay, so x to the power a half. If we look at the other one with bigger exponents, the inside is a 4, the surd exponent is a 3, so therefore the answer would be x to the power 4 over 3. The ones that's on the inside goes on top always. Now let's do a few sums so you can actually see where I apply all of this together. Okay, if we look at this example, I am going to take the numbers first, so the 6 and the -9, and I'm just going to do primary school fractions. So what can go into 6 and 9? And it would be a 3, and I can say, okay, 3 goes in there twice, 3 goes in there 3 times. Okay, and that's where this 2 over 3 comes from. Now I'm looking at the x's, and how do I apply these laws when it's an actual fraction? So we're looking at law 2. It's a fraction, so I'm dividing similar bases. So I'm going to look at the x's. I'm going to see where's my biggest exponent. Okay, so the x has a bigger exponent on top, and that's where I'm going to keep the x's. So always check where's the biggest one, and then you move the other exponents to that one. Now there's an x to the power 1 at the bottom. I'm going to move that to the top. And if I move something in a fraction, it's law 2 of exponents. I'm dividing, and then I'm going to put a minus in front of that exponent. And that's why this becomes x to the power 3 minus 1. If I look at the y's, the 8 is bigger than the 5, and that's why I'm taking this y to the power 5. I'm going to take down to the bigger exponent. And if I move it across a fraction, I need to subtract it. So that is why step 2 looks like it does. Okay, final answer. I just do these little sums, and that's how we get minus 2x squared over 3y cubed. In the next example, we are now applying the rules that involves the brackets. Okay, so the rule said, if I have an exponent inside a bracket, I need to multiply it with the exponent outside the bracket. So we're first going to look at the -5s. So I know this 2 is going to go there, and that just becomes 5 squared, and that's why I'm writing -5 times -5. So that becomes 25. Remember, the minuses cancel out, and that's why it's just 25. Now with the a, there is a 1 already. I just multiply the 1 by the 2, and that's why that becomes a squared. B, it becomes 3 times 2, and that's why it's b6. Okay, I hope it makes sense, guys. This sum just looks like something that comes out of a nightmare. Unfortunately, this is what you're going to get in exams, where you need to apply all the laws at the same time. But as long as you follow a certain pattern, you're going to be fine. Okay, so I have a lot of things going on inside the bracket, and I have an exponent on the outside. You can decide when you want to multiply in the outside exponent. I'm not allowed to tell you must do it first or you must do it last. The easiest way, in all of my experience, I sound like a very old person, but the easiest way is to first simplify everything on the inside and lastly multiply the outside exponent in, but there are teachers that would differ from me. So in this case, I am first going to shift fact all the bases inside. So the 3 to the power 4 comes from the 81, and the 2 to the power 4 comes from 16. Okay, by grade 11, you must know shift fact on your calculator or how to prime factorize numbers. Okay, now I'm going to also look at the x's and the y's. If I look at the x's, up top, there's an x to the power 1 and an x to the power -3. The 1 is bigger, even though it doesn't look like it. The 1 is more positive than -3, and that's why I'm going to take the -3 down to the denominator, and it becomes x to the power 1 plus 3. The y's, I'm going to take to the top. So I am going to simplify the inside of the bracket first, and then in this step, I am going to then multiply this outside exponent, sorry, it was 3 to the power 4, with every exponent on the inside. Okay, that's where the next step comes from, and then I will simplify. So in my second last step, after I simplified all the little fractions, okay, and you're welcome to do this with your calculator, then I'm going to see, okay, everything has a minus, and if something has a minus and there's a fraction, it flips sides. Now we're going to do it step by step. I just wanted to show you a full sum with all the exponent laws. Let's look at this one. So I'm going to do the numbers first. So 4 and 8, I can see 4 goes in there once, 4 goes in there twice. So my first step, I can say this would just be a 1, and this would be -2. Now I'm going to look at the x's, and there's 5 on top and 1 at the bottom. So therefore, I'm just going to say this is x5 minus 1. And with the y's, there's 8 at the bottom and 4 at the top. So I'm going to bring everything down. So remember, I identify where is the biggest of those exponents, and then I move the other exponent towards it. And now I can just simplify. Now, guys, don't get worried about this minus. It can be anywhere in the sum, the top or the bottom or in front. It does not matter. It just looks better if you just write it in front. And the 1, I do not need to write. You can. You'll never lose a mark if you write the 1. But just don't confuse yourself with other sums. So this would just be x to the power 4 over 2y to the power 4. And that's it. The next question. Okay, so I'm going to simplify each bracket first. And I am going to apply, I think it was law 3 in this textbook. So I am just going to multiply this 4 with the 2 and with the 1. So that will give me, let me just make a big fraction for this one. So a to the power 2 times 4 is 8. B 1 times 4, which would just be 4. The next bit, I'm just going to rewrite. There's nothing I can simplify there. Now at the bottom, that's a big one. So now I need to look at the minus 3 and then square it. So I know minus 3 times minus 3 will just give me 9. And now the 5 I need to multiply by 2, so it's a to the power 10. And the b has a squared, and I'm squaring it again, so that just becomes b to the power 4. Okay, so now I need to look at the numbers and then look at the a's and look at the b's. Okay, so let me just change color. There's a 6. I know 3 can go into there twice, and 3 can go into there 3 times. So I'm going to simplify this and say this would just be 2 over 3. Now I can look at the a's and the b's. So there's an a to the power 10 at the bottom. That's definitely bigger than the a to the power 9 at the top. So I'm going to write this as a to the power 10 minus the 8 minus the 1. Okay, law 2. I write one base, and then I subtract the exponents. With the b's, there are 4 plus 3, so there's 7 at the top and 4 at the bottom. So I'm going to say this is 4 plus 3 minus 4. And my final answer to this question would then be 2b to the power 3 over 3a to the power 1. Once again, I do not need to write the 1. Let's now look at the sum. So firstly, I am going to simplify inside the bracket. Now there's only a minus 6. I can't do anything with it. So I'm just going to rewrite it. Now with the a's, there's 3 at the bottom and 1 at the top. So this just becomes a squared at the bottom. With the b's, 2 at the top, 1 at the bottom. So this just becomes b to the power 1 up top. Now remember, this was still all in a bracket squared. And now I can look at the next one and try and simplify that. 3 over 4 just can't cancel or can't do anything with it, so I'm just leaving it there. Then at the top, 4 minus 1 for the a, so there's just a 3 left there, and then b squared. So once again, I am just subtracting the exponents. Now I must first do the square for that bracket, and then I can simplify further. So this would be 6 times 6 is 36, b squared over a to the power 4, and then on the right, it can't change, so I'm just going to rewrite it just like that. And now for my final step, I now just need to simplify everything. So first thing, I see that 4 can go in there once, 4 can go in there 9 times. So now at the top, I have 9 times 3, which is 27. And at the bottom, there's just a 1. So I don't even need to write anything, but I can. Now with the rest, there's 4 a's at the bottom and 3 a's at the top. So that just leaves me with 1 a at the bottom. With the b's, they are now actually exactly the same, which means this b squared cancels out this b squared. Remember, you can write b 2 minus 2, which would become b to the power 0, and we said that is just times 1. So you do not need to write it, but you can if you want to. So the final answer, 27 over a. The next question looks very complicated, but it's actually very easy. So if I look at this, all the bases are just a 3. So I can just say a 3, and then I'm just going to apply law 1 and 2. So law 1 says, if I multiply the same bases, I'm going to add exponents. So at the top, remember this dot means multiply. So I'm just going to say this is x plus 1 plus x minus 3. Okay, guys, so I've marked over 1,000 tests in my life. So many people mistake this dot for multiply in the exponents. That's not what the law says. The law says if you multiply the bases, you must plus exponents. So that's why this must become a plus. Don't mess that up, please. And then with the bottom, 2x minus 4, I am subtracting. So I'm just going to say minus 2x and then minus 4. It's a lot safer if you put it in a bracket. Then you won't make a mistake. Because now I need to multiply that minus in there and it will become a plus. Okay, now I can just simplify. So this is just 2x, and then 1 minus 3 gives me a minus 2, minus 2x plus 4, and you will notice that the 2x's cancel out, and then minus 2 plus 4 just gives me 2. Remember the rule, if you can simplify, please do. So 3 squared will just be a 9. These don't look very complicated, and then the answer is just 9. Math is such an interesting subject. Okay, just 4 more. Remember with me, guys. This is going to be very important in exams, and you're going to use exponent comes in into so many facets of math. So let's go. This one, I am going to simplify on the inside first. So I can see a minus 3 and a 5, just going to stay there. Then with the a's, the 3 is much more positive than the minus 2, so I'm going to bring everything to the bottom 3, and that just becomes 3 minus minus 2, so that just becomes 3 to the power 5. Then with the b's, this is b2 minus minus 1, so that would just be b3. So you are following now with me, so I can just skip those steps and just write it like that. Now all of that is still in a bracket to the power minus 2. And now everything is simplified on the inside, so I can now take the outside exponent, multiply it with everything on the inside. So I'm just going to say this is minus 3 to the power minus 2, b3 times minus 2, 5, 1 times minus 2, and then a 5 times minus 2. And then my final answer would then be, remember, if anything has a negative exponent, it would flip to the other side. Minus 3 squared would be 9. Because there's a minus, the 9 goes to the bottom. Okay, with the 5, it is just 5 squared, which is 25. It has a minus, so it goes to the top. With the b to the power minus 6, goes to the bottom, it becomes positive, and then a to the power 10. Okay, wonderful. That is how you apply all the laws at once. So you can put in as many steps as you want. Please just don't get sidetracked and lost in the middle of this question. Okay, now a bigger question where there's multiple fractions. So let's just simplify each fraction as far as we can and then put them all together. Now, if I look at the numbers, the 3 and the 4 can't simplify, but if I now look at the other parts, it can actually simplify. So I'm going to do that just to skip a few steps. So a 3 and a 9 can cancel each other because the one's at the top and the one's at the bottom. So 3 goes in there once, 3 goes in there 3 times. Now the 8 and the 4 goes in there once, 4 goes in there twice. So now I know in the next step I can write a 2 at the top and a 3 at the bottom if I just look at the numbers. Okay, now with the x's, let's now see. I'm going to add the top x's and I'm going to subtract the bottom x's. So this would be x to the power 2 plus 2, and then the minus 5 at the bottom, I'm moving it to the top so it becomes a plus. Now if I look at the y's, I assumed that the y's are going to go to the bottom, but I assumed wrong. So the y to the power 4 is actually the bigger exponent, so it's all going to the top. I'm just going to move this 3 to the center. So y to the power 4 stays there, and I need to check all the other y's. So the minus 3 top right would just stay there. Okay? It's not moving up or down, so it's just staying there. And the minus 1 will now go up, and this would become a plus 1. Now, simplified answer would be definitely a 2 over a 3, because nothing's going to change that. And then this would be x to the power 9, and then y to the power 2. Great. So remember, there was a law that discussed roots. Let's just revise quickly. So with this first factor, there's a square root of x to the power 3. So I'm going to write a base. The base is x. The inside exponent is a 3. And the outside exponent is a 2. So what's inside goes on top, and the outside one goes to the bottom. Next one, now it's flipped. So the 2 is now inside, that goes to the top, and the 3 is at the bottom. Okay, the bottom one, there's a 1 inside. So this is just x to the power 1 over 6. And now from there, it becomes an easy sum because all the surds are gone, and I can just apply law 1 and 2. So I'm going to write a big X. If I multiply the same base, I add exponents. So 3 over 2 plus 2 over 3, and then I'm dividing, so I am subtracting the 1 over 6. So now by this time, you are in grade 11. You do not need to show all your primary school fraction steps. So I am going to do an LCD and then add the numerators. Okay, but you can really just use your calculator and simplify the answer. And the final answer would just be x squared. The last question we're going to look at is this big one. Okay, looks very, very complicated, but it really is not. Okay, let's go for it. Something that you need to remember, and that I haven't said yet, is if I have multiple factors inside a root, I can rewrite this in this way. So let's go for something like the cube root of a times b. That can be written as a times b to the power 1 over 3, and then I just multiply the outside exponent with each one. Okay, so that's a law that's implied from all the basic laws, but you're going to apply this in many questions. So let's look at the sum. So the 8, I am going to say this is 8 to the power 1 over 3. Because it's a cube root, I need to give each inside exponent a 1 over 3. Then the x would be 2 times 1 over 3, and then the y would be 6 times 1 over 3. The x to the power 1 over 3, nothing happens to it, it just stays there. Now, all of you that studied a lot in primary school will know that the cube root of 8 would just be 2. The other ones, you can just use a calculator, it's really fine. Now, I have 2 x's there, so this will be 2 over 3, and then I add the way back exponent, the 1 over 3 I'm just adding. Okay, this one, 6 times a third would, let me just write it so you don't lose track, and that would just be y squared. But let's now write the final answer. So this is x to the power 2/3 plus 1/3 gives me 3 over 3. That's just the whole. And then 6 times a third just gives me 2. And there is my final answer. Okay, guys, that was a revision of grade 9 and 10 exponents, which you are going to apply in grade 11 and 12. I hope it made sense. Please re-watch this video if you forgot any laws or need to see examples.
If this video helped you, please like and subscribe.
JMath.